Morning everyone, another grey miserable day. Anyway, day 2 of our install of unvented cylinder and LPG boiler. I just wanted to do this little video because I wish I'd really done a video on the install what we did yesterday. So yeah, we installed an LPG boiler and an unvented cylinder, but a special unvented cylinder. Basically the unvented cylinder has an air heat pump on top of it, so basically it has a backward fridge. So instead of cooling your cans of beer, it warms up water. Okay, so when I get on site I think I'll do another little video and show you exactly what we did. Well, great install yesterday, everything went great except we had a little bit of a problem with the heat pump. The fan was a bit damaged on the back of the Ariston cylinder. We'd phoned the manufacturers up and they said, oh no, it's not that, it's this. But anyway, it was the fan, but we got it fixed and we got it up and running. So we need to go back today because it was late when we left yesterday to commission it. So I'll show you the install. But also video went well yesterday, so we put out the video for central heating magnetic filters on our YouTube channel. Few views going up there already, a few likes already, and we've got 236 subscribers now. Amazing. Might get 240 by the end of the year, you'll never know. Anyway, so when I get on site I'll do another little video, but if you haven't subscribed to our YouTube channel, get down there, and while you're there have a look at Katie's new thing she's done. She's won one of them fingernails, toenails, thumbnails, hammer nails, the thumbnails. Anyway, fancy picture on the front of the video, looks great. She's clever, that girl, too clever for her own good hair. Anyway, very clever. So yeah, have a look at that because I was impressed. Hope you were, or you will be. So enjoy all our videos on YouTube. I'll put another video up to go up on our Facebook later. So see you later, have a great day, hope the weather improves, hope the day improves, hope this bloody traffic improves because I hate traffic. Give me back the centre any day. See you later guys. Morning again, what are you nodding your head for? Okay, so we're on the job now, we're on the install. I just want to walk through what we've done. So this first is the Ariston boiler which we've installed. Martin behind the camera, my tech guy. What's this one?
It's the 28 kilowatt E combi one.
Okay, so that's the not the brand new one, but it is brand new. But there you go. It's not the black fronted one, I mean, which would have been nice to go on this job. So we're going to look at that one. The top of the range LTS1 Net is the latest generation of Ariston's thermal condensing boilers, offering heat management with smart conductivity right out of the box, with a patent stainless steel Extratect heat exchanger in 30 and 35 kilowatts. Well, this is the heat pump with the unvented cylinder. What's this one called, tech guy?
This is the Nuos.
Nuos, okay.
The Nuos.
So this is the Nuos. So the way this works, so if Martin comes round, down the side of here is the air in. We've got the air in here, and this is the air out, okay? So this should be ducted out of the wall, depending on the size of your room, and the room size has to be, Martin?
20 metre cubed.
Okay, which we've got 22 metres cubed?
25 metre cubed.
25 metres cubed. So technically, this doesn't have to go outside, because it's not products of combustion, this is just cold air. It's freezing in here. It's absolutely freezing. We walked in this morning. This has been running for a few hours this morning, and it's dropped the room temperature to about 10 degrees. It's freezing. So this does need ducting out. This isn't finished yet. So this lights up all fancy. We'll have a look at that in a minute. So basically, this is a fridge, okay, and this is your unvented cylinder. But what we've done is we've connected it to the combi. So because it's an LPG combi, and the customers are tight. I mean, the customers whinged about the using too much gas. This is where this has come about. So this is our, so if you come in, Martin, this is our hot water out. So what it does is it comes down, okay, so that comes down here, and then it comes up into the hot water for the combi. Now this is set at 50 degrees, Okay, this is at 51 degrees, so this boiler won't actually fire up even though we've got 51 degrees going through. It does know the water's going through there because of the flow turbine, but doesn't actually come in. So this is our cold water in on this one. So it comes in, gets warmed up and then goes out. All the controls are what you would find on a normal unvented cylinder. Okay, so this is our D1. Our D2, again, this is going to be altered, so all you going, it's in solvent well, we can't do it in solvent well. This is only temporary because we're still waiting from the manufacturer to send us the connection. This is the condensate. So this will condensate this cylinder, so we're waiting for this connection. This is why we've got the fancy bucket. So we only installed this yesterday, we're going to commission it today. This still needs to be insulated. Okay, so this all needs to be insulated. We've still got all the ducting to do. So what I'm going to do for our YouTube channel is I'm going to put a series of pictures from the trainee who installed this with us, Nicola. She's, Nicola, happily going to put the pictures on.
Volunteered is the word.
She's giving me funny looks. So she's sending us the pictures over so we can do a step-by-step on installing the boiler and installing this cylinder, and I'll talk over that how we've done it. So this is the future, we hope. Okay, works amazingly. So we're going to get it commissioned and then hand it over to the customer. So before I show you the step-by-step guide on installation with the aid of Nicola's photographs, why don't I try and explain how this cylinder actually works. Now let me try and explain exactly what happens with this air heat pump and combination boiler by the aid of this crude drawing. I'm sorry about the crudity of the drawing, but it's the best I can do. Okay, so this is our cylinder and this is our combination boiler. So what we've got going on at the house is the cold water comes in from the mains. So this is cold water, comes up and then comes into our combination valve. The combination valve is a pressure reducing valve filter like I explained. So if you also watch our videos on unvented cylinders, you'll understand them a lot better. So then the water then comes under reduced pressure into the bottom of the cylinder. Now, what happens with this is, like I explained in the video, this is basically a backward fridge. So by the use of evaporators and compressors, we turn our air coming in, okay, into heat. Now, I've got air coming in at 21 degrees. This is because it's inside that room, so the maximum probably would be 21 degrees. It could be a little bit higher depending on whether we're in the summer or not. Then what it does is it draws out that heat. So anything more than minus 265 degrees, an air source heat pump can take heat out of it, okay, because there is heat in it. So even in minus figures, you're still getting heat. So what it does is it draws the heat out of the air there and then throws it out cold, so it's taking all that heat out. And we got a temperature of around about 10 degrees coming out of this flue system. Okay, that's why it needs to be ducted out, or if in the summer months you could duct it inwards, you've got free air conditioning. So the big coil inside the cylinder now is drawing the heat out. There is also an immersion heater back up here. Because we're only storing this water between 50 and 55 degrees, we need to be able to kill Legionella. So inside there is immersion heater, so every now and again then it warms the water up to over 65 degrees to kill any bacteria what's in there. So like I say, the cold water comes in and then it comes out at 50, well, between 10 and 55 degrees, going now into the cold water inlet for the combi boiler. But this is between 10 and 55 degrees. Okay, it's very rare you get your cold water inlet temperature lower than 10 degrees, but you could do. Okay, so that now comes into the combi. Now the combi will have thermistors in there. What the thermistors will do is they'll monitor the temperature of the water. What's going out depends on whether they need to bring the burner on or not through the plate-to-plate heat exchanger. So this warmed up water will now pass through a plate-to-plate heat exchanger, and the boiler will make the decision whether it needs to come on, whether it needs to be between 50 or 60, depending on what the PCB's been set at. So that boiler then makes the decision, do I need to heat the water or not? So if the water, for every degree the water is over 10 degrees, the boiler will need to use less energy to warm it up to 55, 60 degrees. So it's saving gas, okay? And basically then now that hot water goes off out to the taps, okay? Because this is an unvented cylinder, like I said on the other parts of the video, we require the safety devices in case anything happens to the pressure reducing valve, and that's mainly there to protect the cylinder because the boiler won't need protecting. Okay, the boiler will take the incoming mains pressure. Okay, so basically that's all it does. Cold water comes into the cylinder, preheated by the cylinder, and whatever that cylinder's preheating that water, if you're drawing the water off on the taps, the boiler will decide whether it needs to come on or not. Okay, if it doesn't want to come on because it thinks the water's hot enough, is save gas. Okay, it's as simple as that. Hope that helps. So the first thing Nicola's doing here is marking out where we're going to put the bracket and where we're going to core through for the flue. As you can see now, Nicola's, with all the PP equipment on, is now drilling the centre of the flue hole, getting ready to core out the flue. She's now drilling her holes for the bracket without her PP equipment on. Well done, Nicola. So now we started piping up the boiler. As you can see here, we did some mat press fittings as well as some soldered fittings. Nicola's now just putting in the brackets for the gas pipe. Now we're installing the drainage for the condensate and the blow off, but this time Nicola is wearing a PP equipment. As you can see now, we're starting to put the pipe work in for the cylinder itself. So we're doing the cold water in, the hot water out. You can see Nicola's now using a blow lamp. We're using the mat press gun before, now using the blow lamp, so the trainees get used to using all kinds of jointing methods. You can now see we're getting ready to install the cylinder. Nicola's now blocking off one of the air ports because there was 2 exits for this cylinder and we didn't want it to blow against the boiler. And the last bit on the installation was actually the installation of the cylinder and all its safety controls. Next, we wired the controls into the boiler. We used the Ariston Smart thermostat, the CubeNet 1 I think it's called, into the E-bus connection, which is a low voltage supply. The stat was actually the QBest net, which we temporarily installed into the same room as the boiler and the cylinder, so we could see what the actual room temperature got to with the cylinder putting the cold air into the room. The next thing we had to do on this boiler was set it up for LPG. It actually came out of the Ariston factory set up as a natural gas boiler, but all Ariston boilers come with the restrictors to change them to LPG. This is incredibly easy to do. All you do is put the restrictor in the top of the gas valve and then using Allen keys on the gas valve itself, adjust the parameters for the CO and the CO2 on high and low using the flue gas analyzer. Now it was time to fully commission the boiler and the cylinder, making sure we checked all the safety devices and controls. We couldn't gas rate this appliance due to being LPG, so we did inlet pressure. We obviously did all our flue gas analyzer readings. We did our flow rate and temperature rise at the taps, and checked and made sure that the discharge pipe and everything worked, and the safe operation of all other appliances weren't affected when the boiler was running. Last things to do now was to clean out the magnetic filter and add our inhibitor to protect the system. And the finale is to fill in the benchmark book and hand it over to the customer. The cylinder features an evaporator, compressor, condenser and expansion valve. When the unit is in operation, a refrigerant fluid crosses the evaporator, absorbing heat from the air that has been drawn in by the fan. This process ensures that the refrigerant evaporates, engaging the compressor to increase the pressure of the refrigerant gas, causing its temperature to rise inside the condenser, The refrigerant gas then passes its heat to the water held within the cylinder. This exchange process ensures that the refrigerant starts to return to its original liquid state by condensing, and once it has passed through the expansion valve, the refrigerant fluid loses further pressure and returns to its formative state. Now we've got the cylinder up and running. So you can see the front part, you can see the temperature, I'll make it light, so that's 11 degrees it's made. So far we just literally turned it on from cold. We've got a temperature up at 50 degrees. The throbbing you can hear is actually the fan out of balance, so the broken fan will need to be replaced. But you can see everything's up and running. We've just commissioned the boiler, so we've got all the pictures for that. That's all up and running, tested. So we're just checking now to see what the boiler does once this gets up to temperature. So that's what the cylinder looks like lit up, that's what it sounds like when it's run, and it took the room temperature to 13 degrees before. I just finished watching this video on the Ariston air source heat pump cylinder, the Nuos. If you've enjoyed this video, why don't you give us a thumbs up or leave a constructive comment down below. If you've not subscribed to our YouTube channel yet, get over there and get subscribing and ring that notification bell, because every Wednesday we'll be uploading new videos. So, thanks for listening, thanks for watching, see you next Wednesday.